Okay, vector processor are the SIMD. Okay, single instruction multiple data. It was invented in the 1966. It was developed. Okay, it was developed by the thinking machine company. Okay, thinking machine company. Single instruction multiple data. SIMD is nothing but the single instruction multiple data. It is the one of the parallel computer. Okay, it has the some characteristics here. One is what? Vector registers, instruction set, vectorized and the pipelined functional units, and also interleaved memory, stutter memory, access, hardware, scatter, gather. Okay, these five are the some characteristics here. We'll consider discuss the one by one. Yes, come in. Okay, vector registers. Okay, these are the registers. Okay, these are all the registers which have the capable of storing the one operand. Okay, it has the capable of storing the some data here, and even these vector registers also have the some capability to handle the some operations also. Okay, as you already know this one, accumulator register is there. Yes, sir. A, B, C, D, E. Okay, these are the some registers which are in the processor. Okay, these registers will have the have the capability to store only, but accumulator has its own capability. It has the capability to have the function of doing the some operations also. If you have the accumulator, okay, if you are performing the operation between the C and D, okay, between the registers C and D, the some operations we are performing between these two registers, the automatically the destination register would be what here the accumulator itself. Okay, accumulator itself means what here the accumulator registers have the capability of storing the some operand, and even the some operations also it can operate here. Some operation it means what here the automatically it can store the values also, some operations. Even if you send any values, some registers as the C only one value if you send no, then the automatically this operation purpose only one operation we cannot operate on the single operand value. Okay, single value, so that it will take automatically paired value is taken from the accumulator register only. Means what it is here the operation accumulator register is performing the both the operations, as the it can store the values, and also it can perform the it can send the values, and even it can store the values back also. It means here the some registers are there, some vector registers can capable of storing the some operands, even they can perform on the operations also. Okay, even they can perform it, as the vector registers have the some length. Registers usually we have seen in the normal microcontroller, microprocessor and all, we have the register where storing capability around the 32 bit or 64 32 bit, 16 bit, 8 bits and all. Okay, in the normal 8051 microcontroller we have seen the 8 bit capability of registers, but here the normal, okay, vector processor have the capability of storing the values as the vector length around the 4 to 256. Okay, 256 vector length. Okay, we call this the vector length. Okay, it has the capability of storing the values from the 4 to 256, and we call it what a 64 bit value. 64. Okay, 64 bit. Nowadays whatever we are using the systems, normal desktop and laptops and all, they are all what here the 64 bit of capability. Okay, so they have the capability of storing the values as the 64 bit ones only. It's nothing but the vector registers also have the some registers which have the capability of storing, and even they can perform the operations also. But here the even the vector registers have the capability of vector length is around from the 4 to 256 capability of storing the values, and it's nothing but here it can store around 64 bit operations. Okay, it can operate on the 64 bit of length. Okay, vector length. Okay. Okay, and also next point is here the instruction set. Instruction vector register is over. Okay, next we'll consider the next we'll see the take the instruction set. Okay, instruction set is nothing but the here the these are the as the vector instruction set. Okay, these are the some instructions are there. Okay, these vector instructions are have the capability of operate the only the vector elements. Okay, on the vector elements, not the vector elements are array of data. array of data. Okay, vector registers, sorry, vector instructions can have the operate on the vector data, or else it can operate on the array of data. Okay, it cannot operate on with the scalar data. Okay, even which is having the length of vector length is around the vector length would be here the quite very good here. Okay, quite very good, but its capability of having the what here the some for loop. Okay, if you send the values, some values here, what I equals to 0, I is less than or less than n, and also I plus plus. Okay, if you want to send the some values from the vector x to, okay, if you want to send the some values, okay, from y vector to the y vector to the y vector to the x vector, array to x vector, x array, then we can use the this vector register, sorry, vector registers, vector instructions also. Means vector instructions can have the capability of doing the operations are only vector elements, which can be have the array of data. Okay, these are the we have the, we can say the vector length is around, we can operate only the for loop having the this kind of, for the purpose of having the, for if you want to transfer some values from array of elements from the y to x, then we can perform with the help of what here the vector instruction set also. And also which have the some conventional systems that nowadays requires the add, and also we can perform the operations as the add, store, and also some add, store, sorry, add alla, load, store, and also load, load, add, and also store operations. Okay, if you want to perform these two operations on the particular length of the data, then the definitely we can take the single, okay, single operation we can do it. But in the conventional, nowadays conventional means old processors usually take the separate operations for the single operation. We can load this for loop can have the more than 10 also, 100 also here, whatever you are sending here. It can perform operations with the single load, single add operations, and even single store operations. Okay, with the vector processor. But in the conventional, usually old processor usually will have the separate load, add, and also store operations for the single element. But the vector processors can do the operations with the only only single. Okay, so with the single operations, a load, add, and store, we can send the number of block of data, we can perform on the block of data operations, we can perform the operation on the block of data. Usually old process usually will take the separate separate load operation, add operations, and also store operations for separate single elements. But in the bulk only we can operate operation, we can perform the load, add, and store operations with the only single operations with the help of the vector instruction set. Okay, vector instructions. Next we will see the interleaved memory. Okay, what is the interleaved memory and pipeline? Interleaved memory pipeline is nothing but the, if you have the block of data, okay, bank 1, bank 2, bank 3. Okay, if you are doing the some block, okay, even you can say the block of data and even bank of data, if you are performing the some operations, okay, if you are accessing the first element, then the next elements also will be accessing, and also third elements also we are accessing, we are performing. If you want to do the some operations back to the on the particular first operations, then we now it will take more time to access the older element, already accessed element. Okay, means what here the, we can perform the one by one, but if you are reusing the particular register values, if you are reusing the particular block of data, then it will take the more time here, somewhat time. Okay, if you are performing independently operating on the different blocks of memory, then definitely it will take the less time. If you are reusing the particular block of data or block of memory, definitely it will take the somewhat more time. Okay, reusing means what, it is consume the time. Okay, this is we call as the interleaved memory also. Okay, okay, this one we call as the interleaved memory. Okay, interleaved memory. Okay, usually interleaved memory will take the little time to access the reused elements. Okay, reused, if you are performing the particular separate operations as bank 1, bank 2, bank 3, whatever it may block, whatever it may be, if you are doing, if you are reusing the particular block of data or block of memory, then definitely it will take the consume the somewhat time. Okay, this one we call as the interleaved memory. Interleaved memory. Okay, next we consider the studded. Okay, studded means what, stud means what, somewhat we are jumping the elements from the 1 to, directly we will access the 1 agado fifth one element, fifth agado we can access the ninth one element. Okay, this one we call this stud means what, here the we are performing the jumping the sum between the elements. Okay, it's where the studded memory access with the program access elements vector loaded fixed intervals, we will be performing the some fixed intervals. ಏನಾಗ್ತಿದೆ ಇಲ್ಲಿ, ಸ್ಟಡ್ಡೆಡ್ ಮೆಮೊರಿ ಆಕ್ಸೆಸ್ ಅಂಡ್ ದಿ ಹಾರ್ಡ್ವೇರ್ ಸ್ಕ್ಯಾಟರ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ದಿ ಸ್ಟಡ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ದಿ ಸ್ಟಡ್ interval, some interval of time. Stud means what, gap time. Okay, it will jump from the first to fourth to ninth, like this. Okay, in the stored memory, in studded memory access, the program access elements and the vector elements can be studded with the some particular period of time. Here the, for example, if I consider the stud means what, we will be jumping. Okay, stud means from the first element to next is what, fifth element. Fifth element to what, we are jumping from the fifth to ninth. Means here the stud is what, here the stud values here, what stud length is what, here 4, 1 to fifth, 5 to ninth, means what, stud values here, the stud length is what, 4. Okay, 4. Okay, stud value is 4. Usually stud using the stud only will be handling the block of data using, instead of you say accessing the single data, instead of accessing the ಒಂದೊಂದು ಡೇಟಾ ಎಕ್ಸೆಸ್ ಮಾಡೋ ಬದಲಿ ವಿಲ್ ಬಿ ಟೇಕಿಂಗ್ ದ ಅಸ್ಟ್ ವಿತ್ ದ ಕಾನ್ಸೆಪ್ಟ್ ಆಫ್ ಸ್ಟಡ್ ವಿಲ್ ಟೇಕ್ ದ block of data here. Block of data is nothing but the 4, we are jumping the some values from 1 to 4, 5 to 9 only. Means what, here the block of data we are sending here 1 to 4, 4 to 9. Means stud length is what, here the 4. Stud length is what, 4. Okay. Okay, and also we have seen the studded memory is nothing but the will be accessing the particular memory with the stud. Okay, means what, stud length will be fixed here. Okay, if you are using the scatter and gather, scatter andre enagutta, read, scatter right agutte. Okay, scatter and gather, here the scatter andre right agutta and gather andre read agutta. Okay, here the first here the scatter and read the elements vector located in the irregular fashion. Okay, if you are using the scatter gather concept here, we can access the irregular elements, but in the stud memory access will be accessing the particular period of stud. Okay, but if you are using the concept of the scatter and gather, there will be using the irregular elements, there will be no access particular period of time. Okay, then here if you consider the first and second, even you can jump directly to the fifth element, and also even we can access the eighth elements also. But here the stud is not fixed here, means particular fixed period of time is not fixed, particular fixed interval time is not fixed here. But thing is that here the we can access the any element with the directly. Okay, but in the stud only we have the particular interval of time there. Okay, this week is we have seen in the, okay, scatter and gather is nothing but, scatter is nothing but the here the write. Okay, write and read operations can be worked with the work with the some without any interval of time, means irregular interval of times. Okay, we can access the different elements with the any time. Okay, first element, second element, even fourth, eighth elements also we can access without any, we don't have the any particular interval of time, means what, it's the irregular period, irregular interval of time we can access the memories also. Okay, and I left it here the vectorized and pipelined functional unit. Vectorized means what, here the some operations, if you want to do some operations. Okay, one element with the second element with the third element with the fourth element, means what, we are doing the some operations as like ಏನು ಮಾಡ್ತಿದ್ದೇವೆ, ಫಸ್ಟ್ ಎಲಿಮೆಂಟ್ಸ್, ಸೆಕೆಂಡ್ ಆಪರೇಷನ್ಸ್ ಅಂಡ್ ಥರ್ಡ್ ಆಪರೇಷನ್ಸ್. ಓಕೆ, ವಾಟ್ ಎವರ್ ಇಟ್ ಮೇ ಬಿ, addition of the numbers, whatever some operations here. For performing the operations between these two will be first one. Okay, first one. After the getting the result, this can be added to or subtracted to the third. Okay, here the operations are here the vectorized, means what, here the vectorized one by one. Vector is nothing but the, it has the directions. Okay, it has the direction. Without performing this particular these two operations between the these two elements, will not perform the third element operation here, means what, here vectorized means what, it's going some directions. Okay, later, okay, we are performing what, some pipeline. Okay, we are performing the particular operation within this interval of time, and after performing this result only, the same result is added or subtracted with the particular of period of times. It's nothing but we are doing the operations with the pipelined manner also, pipelined manners. It's nothing but the vectorized and pipelined functional units. Okay, whatever the units, if we are using the our computer, whatever we have the some functional units, they can perform the operations with the serially, like what, here the operations between the these two elements. After getting the result only, we'll be adding or subtracting to the third element. Here the vectorizing means what, here going in the one direction here, and also we have the performing the some operations which will be from the one step between the two elements. Next third elements only we will be doing, without performing the operation of the first two between the operation between the these two elements, will not go for the third third element. It's nothing but here the vectorized, and also we are performing the pipeline. Okay, first operations here, the next interval of time is we are performing the next operation here. Here the, it's nothing but here the vectorized and pipeline functional units. Okay, these are the some characteristics of the vector processor. Okay, as we have seen the instruction set, vector registers, and also vectorized and pipeline functional units, and also interleaved memory, and also studded memory and access. Okay, okay, this is the concept of the vector processor. They will ask for the 5 marks or 10 marks. Okay, vector elements will have the sum of advantages, as it has the capability of many operations we can perform. We can use the very easily, we can use this concept very easily in the computer, and also we have the identifying the code easily. If you want to perform the some operations on the particular code, okay, then definitely a vectorized vector processor can identify easily, vector processor can easily identify that particular code. And also we can do the some operations like loop, for loop and all. But in this disadvantage main here, the particular operation of the loop operations we cannot do here. First, if you want to do the loop operations particularly, it will take the less time. Okay, it will take the less time because of the some period of time, and even you will be using the operations add, ಯಾವುದು ಲೋಡ್ ಆ್ಯಡ್ ಮತ್ತು ಸ್ಟೋರ್ ಆಪ್ರೇಷನ್ಸ್ ಫಾರ್ ದ ಪೀರಿಯಡ್ ಬ್ಲಾಕ್ ಆಫ್ ಡೇಟಾ, ಅಲ್ಲಿ ಸ್ವಲ್ಪ ಲೆಸ್ ಟೈಮಲ್ಲಿ ವರ್ಕ್ ಆಗುತ್ತಂಥದ್ದು. Vector systems can have the high bandwidth memory. Okay, we can have the high bandwidth of memory because of we are sending the vector length is around the 4 to 256 to 4 to 256 irutte. Okay, main disadvantage of this is nothing but the they don't handle what here the irregular data structures, handle ಮಾಡಕ್ಕಾಗಲ್ಲ. ಇದೇ main drawback of this vectorized processor. Okay, take the heading as the vector processor. Take the some notes, write down. Vector processor. Okay, I hope you have copied this one. Okay, first you consider, take the vector registers. vector registers. These are the registers capable of, okay, you copy this one. Vector processor is the SIMD processor. A vector processor was invented in the 1966. It was invented by the Thinking Machine Company. Okay, later the vector processor can have the some characteristics like instruction set, vector registers, vectorized and pipelined functional unit, and interleaved memory and studded memory access. Studded memory access with the um, and also, and one more concept is there, hardware scatter and gather. Okay, in that we will consider first one as the vector registers. Okay, vector registers, these are the registers, these are the registers, these are the registers capable of storing a, these are the registers capable of storing a vector of operands, vector of operands, vector of operands, vector of operands, and 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 operating simultaneously on their contents, operating simultaneously on their contents, and operating simultaneously on their contents. Here the vector length is fixed. Here the vector length is fixed by the system. Here the vector length is fixed by the system and can be ranged from, and can have the range from, and can range from, and can have the range from 4 to 256, 4 to 256, 4 to 256 as 64-bit elements, as 64-bit elements, as 64-bit elements. Okay, next consider as the, okay, next take the point as the vector, vector register ಆಯ್ತಾ. next vector instructions ಅಂತವ್ರಿ. Okay, these are the instructions which will be used for the for the operations. The registers can hold the some values here, okay, some data, and even the register, these instructions can perform the some operations. Okay, okay, these are the instructions, these are the instructions, these are the instructions, can operate on vectors rather than scalars. ವೆಕ್ಟರ್ ಮೇಲೆ ಆಪರೇಟ್ ಮಾಡ್ತಾವೆ, ಸ್ಕೇಲರ್ಸ್ ಮೇಲೆ ಮಾಡಲ್ಲ. They can perform the operate, they can operate on vectors rather than scalars. If the vector length is, if the vector length is, if the vector length is vector underscore length, okay, just if the vector length is vector, if the vector length is vector, okay, if the vector length is vector length, vector length, okay, have the great virtue that a simple loop, great virtue on simple loop, great virtue on simple loop. Okay, that's nothing but we have the, it has the capability of work on the some simple loops also. Okay, you take the for loop as the for I equals to 0, I is less than n, I plus plus, we have the two vectors here, the array of vectors here, I of x and plus, okay, plus equal I of y. Here the some elements from the y to, we are adding where in the from y to x. That's what I use these two operations as plus and equal. Take that one. Okay. Above for loop, above for loop requires only what? Here the single requires only single load, single load, add and and store of each block of store of each block of vector length elements. Okay, if you are sending the performing some operations and the for loop that's nothing but having the some range vector length, then definitely we can perform with a single load, add and the store operations. Okay, okay. While other conventional system may require the separate for the these three operations for the single elements, but here the we are doing the sum operations. Next, while a conventional system requires a load, add and store of each element, while conventional system requires load, store, load, add, store for each element, but there we require only the for loop purpose. We have in the for loop we will have the many elements. Okay, those many elements, block of elements will require take only the single single load, add and store operation, but here the conventional system, other system will take the separate load, add and store operations for the each element. Okay, for each element. Next, consider the vectorized and pipeline functional unit. Vectorized and the pipeline functional units. Take the vectorized and pipeline functional units. Some operation is applied to each element. Okay, same operation, same operation is applied to each element. Here 1 plus 2 is adding next operation, we can perform the same operations. Okay, if you are performing the same operations means what? 1 plus 2, and also same operation is applied to the 2 plus 3 only. After performing the addition between these two elements, then only we will go for the third element. Okay, it means here the we are giving the vectorized means what? Vector means some direction, it is giving perform the first only, it will go for the second, it will perform the second only, it will go for the third and fourth element. It means what? Vectorized. And also we have performed the some operations with the pipelined means what? Pipelined means pipelined. Okay, okay. The same operation is applied to 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 each element of the vector, each element of the vector, each element of the vector, each element of the vector. In case of vector is in case of this in this case we will have the same operations means some operators. Okay, okay. Or in the case of operations as or in the case of operations applied between the pair of elements, in the case of operations applied between the pair of elements, pair of elements, pair of elements as like addition operation, as like addition operations, okay. Usually vector operations are applied in the fashion of the pipeline only. Okay, pipeline manner. Okay, this one operation. Next point, vector operates are vector operations are SIMD, single instruction multiple data. Here we single instruction means what? Here single instruction andre enagutte ಇಲ್ಲಿ we are performing only what? Here the addition operation, only operation is what? Single instruction. Multiple data means what? We are taking the multiple data one by one. Next one, second, third, fourth operation. Means what? Here the single instruction means what? Here the addition operation. Okay, we are doing the same operation means what? A single instruction. We are performing on the multiple data here. 1, 2, 3, 4, 5. Means what? Here the vectorized vectorized and pipeline operations would be here what here the SIMD means what a single instruction multiple data. Okay, take the vector operations are SIMD means what single instruction multiple data means we are single instruction is we are what addition operation and the multiple data is nothing but the number of elements here the number of elements. Okay, so that it is a pipeline. Next point, so that it is a pipeline. Okay, next point here is the okay interleaved memory. Interleaved memory. Okay, the memory consists of the multiple banks. The memory consists of the multiple banks. The memory consists of the usually memory are divided into number bank. Okay, it's nothing but the banks are consist of the number of registers means number of blocks are there. Okay, the memory system consists of the multiple banks that can be accessed more or less independently. Okay, as I already told you that. Okay, some banks. Okay, if you want to reuse the older element, then it will definitely it will take the less time. Okay, somewhat time. If you are operating on the independently, okay, if you are operating the independently with the different banks of elements, definitely it will consume the less time. If you are reusing the particular bank of the elements, some elements, definitely it will take consume the somewhat time, less time, some time. Okay, that is also okay that we call the interleaved memory. Okay, okay, can be accessed more or less independently after accessing the bank. Okay, after accessing the one bank, after accessing the one bank, after accessing the one bank, there will be delay before, there will be delay before it can be re-accessed. There will be delay before it can be re-accessed. But different bank of elements can be accessed very sooner. Okay, very soon. But if you are accessing the reused, okay, if you are performing the operations on the older means already used bank of elements, then definitely it will take the somewhat time. Okay, so that it can if the elements of the vector are distributed across the multiple banks of the, then the definitely okay multiple data means what here the independently we are accessing means what, then there will be no time. Okay, if you are using okay ಇದು ತೆಗೆದು ಯೂಸ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಸ್ವಲ್ಪ ಟೈಮ್ ತೋರ್ತದ ಇದು ಮತ್ತೆ ಆಪರೇಟ್ ಆಗ್ಬೇಕಾದ್ರೆ ಸೇಮ್ ಅದೇ ನಾವು ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಗಿ ಸಾಮಾನ್ಯಗಳು ಆ ಕಡೆ ಬಿಟ್ಟಿದ್ರೆ ವಿ ಕ್ಯಾನ್ ಈಸಿಲಿ ಫೆಚ್, ವಿ ಕ್ಯಾನ್ ಈಸಿಲಿ ಟೇಕ್ ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ elements. But we are doing the some operations on the particular reused elements less ಸ್ವಲ್ಪ ಟೈಮ್ ತೋರ್ತದೆ. ಈಗ ಪ್ಲೇಟ್ಸ್ ಆಫ್ ಇದು ಇಟ್ಟಿರ್ತಾರೆ, 4ನೇ ಪ್ಲೇಟ್ ತೆಗಿಬೇಕಾದ್ರೆ ತೆಗಿಲೇಬೇಕಾ ಟಕ ಟಕ. ಒಂದು ವೇರಿ ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಗಿ ಎಲ್ಲ ಕಡೆಗೆ ಇಟ್ಟಿದ್ವಿ ಅಂದ್ರೆ ಟಕ 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 ತಗೋಬಹುದು. ಓಕೆ, ಇಟ್ಸ್ ನಥಿಂಗ್ ಬಟ್ ಹಿಯರ್ ದ ವಿ ಆರ್ ನಾಟ್ ಇಫ್ ದ okay take the next. So if the elements of the vector are distributed, if the elements of the if the elements of a vector are distributed across multiple banks, then there will be no delay. ಅಲ್ಲಿ ಡಿಲೇನೇ ಇರಲ್ಲ, ಯಾಕಂದ್ರೆ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗಿರ್ತೀವಿ, ವಿ ಕ್ಯಾನ್ ಆಕ್ಸೆಸ್ ಇಂಡಿಪೆಂಡೆಂಟ್ಲಿ. ಓಕೆ, ವಿ ಕ್ಯಾನ್ ವೆಕ್ಟರ್ ಅಂತ ಹೇಳ್ತಿದ್ದೀನಿ ಎಲ್ಲ ಟೈಮಲ್ಲಿ, ವೆಕ್ಟರ್ ಅಂತ ಯೂಸ್ ಮಾಡ್ತಿದ್ದೀನಿ. ವೆಕ್ಟರ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ದಿ array of elements. ಓಕೆ, array of elements which have the some directions. ಓಕೆ, ವೆಕ್ಟರ್ ಅಂದ್ರೆ array of elements which have the some directions. Okay, we call it the vector elements here. Next point take as the studded memory and next point studded memory access and the hardware scatter gather. In the studded memory access, the program The program access elements of the vector, the program access elements of a vector are located at fixed intervals. Fact, a fixed interval. Stud means what here? The ಒಂದು ಡಿಫ್ರೆನ್ಸ್ ಒಂದು ಸಮ್ ಪೀರಿಯಡ್ ಆಫ್ ಇಂಟರ್ವಲ್ ಆಫ್ ಟೈಮ್ ಈ ಥರ ಇದೆ. ನಾವು ಸಿಂಗಲ್ ಒಂದು ಹೆಜ್ಜೆ ಹಾಕಿದ್ರೆ ಓಕೆ ಆಗುತ್ತೆ. ಅದೇ ನಾನು ದೊಡ್ಡ ಹೆಜ್ಜೆ ಹಾಕಿದ್ರೆ ಐ ಗ್ಯಾಪ್ ಫಾರ್ ಒಂದೆರಡು ಹೆಜ್ಜೆ ಬಿಟ್ಟು ಗ್ಯಾಪ್ ಮಾಡ್ದಂಗೆ ಅಂದರೆ ದಾಪುಗಾಲು ಹಿಂಗೆ ದೊಡ್ಡ ಹೆಜ್ಜೆ ಹಾಕ್ತೀವಿ ಅಂತೀರಲ್ಲ ಆ ಥರ. ಸ್ಟಡ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ದಿ ಆರ್ ದ ವಿ ಆರ್ ಫಿಕ್ಸ್ಡ್ ಇಂಟರ್ವಲ್ ಆಫ್ ಟೈಮ್. ಯಾ ಫಿಕ್ಸ್ಡ್ ಇಂಟರ್ವಲ್ ಆಫ್ ಟೈಮ್. ಓಕೆ, ಫಿಕ್ಸ್ಡ್ ಇಂಟರ್ವಲ್ ಆಫ್ ಟೈಮ್. ಓಕೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೆಕ್ಸ್ಟ್ ಬರ್ಕೋರಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇದು ಹೇಳಿದ್ನಲ್ಲ, ಅದು ಬರೀರಿ 1 4 ಫಸ್ಟ್, ಆಮೇಲೆ 5th, ಆಮೇಲೆ 9th. Means what here the stud is what here the 4. Stud is what here the fixed 4 only. Okay, we are accessing the some elements. Okay, with the stud value. Okay, this one is the stud memory access. Okay, stud memory access. Okay, if you are doing the some operations as the scatter, write and read operations without any some interval of time. Okay, we will be taking here what here the first element, second elements also, and also we will be accessing directly 5th element, 9th element. Here the fixed value, there is no fixed interval here. There is no fixed interval here in the hardware scatter, but in the stud accessing there will be fixed interval of time. That one we call as the stud. Okay, fixed length. Okay, okay, for example first element, 5th element, 9th element, and so on. Okay, these would be stud access with the particular fixed length. Okay, that's nothing but the 4. Okay, ಬರ್ಕೋರೋದು, write down it. ಫಸ್ಟ್ 5th 9th ಮತ್ತೆ ಸೆಕೆಂಡ್ ಇನ್ ದ ಸ್ಕ್ಯಾಟರ್ ಗ್ಯಾದರ್ನಾಗ ಏನು ಬರ್ಕೋತೀರಿ, ವಿಲ್ ಬಿ ರೀಡ್, ರೈಟ್ ಅಂಡ್ ರೀಡ್ ಬರ್ಕೋರಿ. ರೈಟ್ ಅಂಡ್ ರೀಡ್. there you could be taking there is no interval, particular period of interval. Okay, we can access the independently, we can be doing there is no interval of time. Main advantage of this vector processor is nothing but we have we can do some operations on the loop of elements with the less time only. We do some operations on the loop of elements on the vector with the particular less time only. Even we will be having make the decisions very faster. Okay, in the possible manner. Okay, in the possible manner. And also vector systems have the very high bandwidth of very high memory bandwidth. Okay, main disadvantage of this is we cannot operate on the irregular data systems. We cannot do on the irregular data system. Okay, currently nowadays we are using the almost all in each and every computers we will be using the vector processor only, vector processor operations only. Many of the systems will be using this one. Okay, next take the heading as the graphic processing units. Okay, okay, graphics card, usually you have seen the graphics card and all. There we will be using the real-time applications as the real-time graphics. Usually you have some APIs, you know, APIs means what? Application programming interfaces. So we will be using some operations as this one. If you have any picture here, if I have the picture as the human, okay, this can be divided into number of pixels, okay, number of lines, and also number of triangles. Okay, usually the pixels, okay, picture of the pixels will be divided into number of pixels and also points, number of points, and also lines, point to point connection with will be done with the lines, and also triangles. Okay, they use the graphical processing pipelines as with the particular representation purpose, and also several of these pipeline operations usually done with what here the pipelined, okay, pipelined manner also. Okay, this can be divided into points, lines, and also we'll have the triangles. Okay, okay, real-time graphics APIs usually have the some applications, some points, lines, and also triangles. Okay, internally represent the surface of the any object here, surface of the any object. If you have the object as the picture, okay, whatever it may be, if you have the data, whatever the object here, if you have the picture image, okay, this can be real-time application, real-time graphics usually interfaces. Then the human being can be graphics. If you use the graphics card, this can be divided the human picture itself as the real-time applications with some APIs as the points, lines, and also triangles. Okay, as the points, lines, and the triangles on a surface of the object, on a surface of the object. Thereafter will be image. Okay, thereafter this image can be processed with the some graphical processing pipelines. Okay, graphical processing pipelines. Okay, okay, several of these stages can be pipelined. Okay, of whatever you are processing the pipeline with the whatever we are processing the image, no, that one can be processed, that can be pipelined here, pipelined. Okay, pipeline, this behavior can be done with the some piece of code here. Okay, that one is called the shader shader function. ಈ ಶೇಡರ್ ಫಂಕ್ಷನ್ ಅಂದ್ರೆ ಏನಂದ್ರೆ ವಾಟ್ ಈಸ್ ದ ಶೇಡರ್ ಫಂಕ್ಷನ್ ಮೀನ್ಸ್ ಇಟ್ಸ್ ಎ ಸ್ಮಾಲ್ ಪೀಸ್ ಆಫ್ ಸಿ ಲ್ಯಾಂಗ್ವೇಜ್ ಕೋಡ್. ಓಕೆ, ಸಿ ಲ್ಯಾಂಗ್ವೇಜ್ ಕೋಡ್ ಇರುತ್ತೆ. ಈ ಸಿ ಲ್ಯಾಂಗ್ವೇಜ್ ಕೋಡ್ ಸ್ಮಾಲ್ ಪೀಸ್ ಆಫ್ ಸಿ ಲ್ಯಾಂಗ್ವೇಜ್ ಕೋಡ್, ದಿಸ್ ವಿಲ್ ಬಿ helpful for us to image processing purpose, whatever the processing of the graphics units. Okay, if any object is there, that can be divided into number of points, lines, and so triangles. Okay, these points, lines, and triangles can be processed graphically with the help of what here the pipeline. Okay, this pipeline operations can be done with the help of what some shader function. Shader function is nothing but some methods are there, some methods or functions are there. This can be written with the help with the C language code only. C language code. Implicitly, these they are all what here the parallel operations. Whatever we are doing the operations with the some graphics processing units, GPUs. Okay, this can be done with always with the parallels, in the parallel manner. Okay, parallel the pipeline operations, graphical. Okay, graphical processing units of these operations can be pipelined. Okay, this pipeline can be done with the parallel computing only. Okay, this is usually the current generation systems are usually have the GPUs. This what was graphic processing units usually current generation system. Okay, whatever we have the systems will have the always we have the some ಏನಿರುತ್ತೆ ಗ್ರಾಫಿಕ್ ಕಾರ್ಡ್ ಇರುತ್ತಿಲ್ಲ, ಎಲ್ಲ ಸಿಸ್ಟಮ್ನಾಗ ಗ್ರಾಫಿಕ್ ಕಾರ್ಡ್ ಇರುತ್ತಲ್ಲ, ಆಗ ಕರೆಂಟ್ ಜನರೇಷನ್ ಸಿಸ್ಟಮ್ ವಿಲ್ ಹ್ಯಾವ್ ದ graphics card. Okay, graphics card. If you want to process any single image, okay, if you want to process a single image, it might take the one period of um, MB. It's nothing but the 100 MB. ಒಂದು ಪಿಕ್ಸೆಲ್ ಆಫ್ ಏನಾದ್ರು ತೊಗೋಬೇಕಾದ್ರೆ ಸಮ್ MB ತೊಗೋತದೆ ಅದು, ಯಾವುದೇ ಒಂದು ಗ್ರಾಫಿಕ್ಸ್ ಹ್ಯೂಮನ್ ಆಬ್ಜೆಕ್ಟ್ ಆಗಲಿ ಯಾವುದೇ ಒಂದು ಆಬ್ಜೆಕ್ಟಿಗೆ ಪ್ರೊಸೆಸ್ ಮಾಡಬೇಕಾದ್ರೆ. Okay, it will take around the 100 MB. Okay, for particular accessing of the data. Main drawback of this GPU is nothing but this, it has the some poor performance is there because of the it will take the less block of less MB. Okay, it's less MB. Okay, always GPU are always not a depend on only CMD and MIMD, means what single instruction multiple data and multiple instruction multiple data. It's not depend on it is not working on only what SIMD or MMD. It can work on both the SIMD and MMD only. Okay, take the heading as the graphic processing units. Take the heading as the graphic processing units. Okay, real-time applications, real-time graphics, APIs, real-time graphics APIs. ಬರ್ಕೋ ಟೈಮ್ ಆಯ್ತಾ ಹಾಂ ರಿಯಲ್ ಟೈಮ್ ಗ್ರಾಫಿಕ್ಸ್ APIs, real-time graphics APIs, real-time graphics APIs, API ಇದ್ದಲ್ಲಿ ಬರ್ರಿ application programming interfaces. Use the points, lines and triangles. Use the points, lines and triangles for representation of surface of the object. Surface of the object for representation of the surface of the object. For representation of the surface of the object. Okay. Usually GPU pipeline can convert the number of pixels into pipeline can convert the number of pixels into pipeline operations. Pipeline operations. Pipeline operations for a array of pixels that can be sent to computer screen that can be sent to a computer screen. Okay, several of these stages can be programmable. Okay, these are the several of these stages can be programmable. Next point. Several of these stages can be programmable. Okay, how can be done this one programmable? With the help of the shader functions. Okay, these shader functions are the small piece of C language code with this programmable. Okay, with the programmable, the behavior of the programmable stages, the behavior of the programmable stages is specified by the shader functions. Okay, next, shader functions are nothing but the small piece of C language code. Small piece of C language code. Okay, ಈ ಬುಕ್ಕಲ್ಲಿ ಈ ಸಬ್ಜೆಕ್ಟಲ್ಲಿ ನಾನು ಯಾವುದೇ ರೀತಿ ಕೋಡ್ ಯೂಸ್ ಮಾಡಿದ್ರೆ ನಿಮ್ಮದು ಏನು ನಿಮ್ಮದು ಲ್ಯಾಬ್ ಇದೆ, ಇಂಟಿಗ್ರೇಟೆಡ್ ಲ್ಯಾಬ್. ಓಕೆ, ಈವನ್ ವಿ ಹ್ಯಾವ್ ದ ಇಂಟಿಗ್ರೇಟೆಡ್ ಲ್ಯಾಬ್. ದೇರ್ ಐ ವಿಲ್ ಬಿ ಯೂಸಿಂಗ್ ವಾಟ್ ಕೋಡ್? ಯಾವ್ದು ಕೋಡ್ ಯೂಸ್ ಮಾಡ್ತೀನಿ? ಸಿ ಲ್ಯಾಂಗ್ವೇಜ್ ಯೂಸ್ ಮಾಡ್ತೀನಿ. ಓಕೆ, ವಿತ್ ದ ಸಮ್ ಅದರ್ ಟೂಲ್ಸ್. ಓಕೆ, ಸಿ ಲ್ಯಾಂಗ್ವೇಜ್ ಯೂಸ್ ಮಾಡ್ತೀನಿ, ಮತ್ತೆ ಯಾವುದು ಯೂಸ್ ಮಾಡಲ್ಲ. ಓಕೆ, ಬೇರೆದು ಯಾವುದು ಜಾವಾ ಪೈಥಾನ್ ಏನು ಯೂಸ್ ಮಾಡಲ್ಲ. ನಾನು ಬೇಸಿಕ್ ಸಿ ಲ್ಯಾಂಗ್ವೇಜ್ ಯೂಸ್ ಮಾಡ್ತಿರ್ತೀನಿ ಫಾರ್ integrated lab. I will start after completion of this first module. Don't come and ask me, okay sir, lab ಅಂತ ಕೇಳಕ್ಕೆ ಹೋಗ್ಬೇಡ್ರಿ. ನಾನು ಇಂಟಿಗ್ರೇಟೆಡ್ ಲ್ಯಾಬ್ ಇರುತ್ತೆ, ಐ ವಿಲ್ ಕಂಪ್ಲೀಟ್ ವಿದಿನ್ 4 to 5 ಡೇಟ್ಸಲ್ಲಿ ಮುಗಿಸ್ಬಿಡ್ತೀನಿ. ಓನ್ಲಿ 9 programs I have, 4 programs which I can execute independently on the online only. Even after the 5th ನಿಂದ 9th ವರೆಗೂ ಪ್ರೋಗ್ರಾಮ್ಸ್ ಏನಿದಾವಲ್ಲ ಅವು ಮಾತ್ರ I need a tool. Okay, some tool I need there. Even for 1 to 4 you can work, you can execute those programs on the online only in the Google itself. Okay, I prepared that document. I need some more programs, so that I'm doing the searching that programs. Okay, I'm not getting programs usually. I need to write that one for. Still, I'm under the process of preparing that document. Inna prepare pura complete ಆಗಿ ಮಾಡಿಲ್ಲ. I'll be preparing. Even complete. Next point. For processing the single image can require can require large amount of data. Large amount of data as 100 MB. For processing a single image, processing a single image can require very large amounts of data as hundreds of MB, hundreds of MB, hundreds of MB. Okay. Okay, drawback of this GPU is nothing but it's here the keep the data path always busy, and the it will have the poor performance because of you are using what here the hundred of MB we are accessing, we are performing, we are any image, if you have the some images that can require the large amounts of data to process particular data image, so that it will be taking the large amount of time also. Even we have the data paths will be always busy one by one another, okay, for processing the particular image. Okay, this is the main drawback of this one. Usually graphic processing units usually work on the SIMD only. Sometimes it will work on the both, even on the SIMD and even MIMD also. Okay. Okay, what is time now? uh, what is time now? 11. I have the still 5 more 15 minutes time, no? Okay, take the heading as the MIMD. ಎಲ್ಲಿ ಎಸ್ ಬರ್ತದ ಅದು ಸಿಂಗಲ್, ಐ ಇದ್ದಲ್ಲಿ ಇನ್ಸ್ಟ್ರಕ್ಷನ್, ಎಮ್ ಇದ್ದಲ್ಲಿ ಮಲ್ಟಿಪಲ್, ಡಿ ಇದ್ದಲ್ಲಿ ಡೇಟಾ. ಯು ಶುಡ್ ರಿಮೆಂಬರ್. ಸಿಮ್ ಅಂದ್ರೆ ಸಿಂಗಲ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಮಲ್ಟಿಪಲ್ ಡೇಟಾ, ಎಮ್ ಅಂದ್ರೆ ಮಿಮ್ ಅಂದ್ರೆ multiple instruction, multiple data. Now we will consider for the already we have studied about the SIMD means what? Single instruction. We are performing the you are single instruction ಅಂದ್ರೆ single operation addition ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. It will operate the same operation, addition operation is doing on the multiple data 1 2 3 1 plus 2 plus 3 plus. Okay, ಆ ಥರ ಇಟ್ಕೊಳ್ಳಿ. Okay, sim means what? Some operation, single instruction, multiple data. We have seen this one. Okay, now we will be considering that as the MIM. MIM means nothing but the okay, multiple instruction, multiple data, multiple instruction stream on the multiple data. Okay, these are the multiple instruction, multiple data are the nothing but the are the system support on the multiple instructions simultaneously work on the multiple data. Okay, usually we will be taking the will be streaming here the multiple instructions. Even these instructions can operate on the what here the multiple data here, multiple data. Okay, multiple instruction and multiple data stream. Okay, this is the one of the classification of the Flyn's taxonomy classification. This one is the MIMD. Okay, MIM is nothing but the multiple instruction, multiple data. Here the multiple instructions we are sending simultaneously, which will work on the simultaneously on the multiple data here, multiple data. My MIMD is consist of usually collection of independent processing units. Okay, usually we have the collection of number of units. Okay, processing units. There we will be studying. We have seen the only single processor we have seen in the vector processor. Okay, vector processor. But in MIMD ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, multiple processor we are using. Okay, number of processor are here the more here. Okay, number of processor are more here, and also MIMD are asynchronous. We are asynchronous means what? We don't have the global time, global time over here. Okay, global time. Even the MIMD are performs there is no relation. Okay, no relation between the systems time. Okay, one by one. If I have the two systems two systems are there. The system's time from the one system to another system will be independent. Okay, independent means what? Here the we are not synchronizing the times here. Means what? Here the same time you are not using because of the multiple instruction, multiple data. ಈಗ ಸಿಂಗಲ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಇತ್ತಂದ್ರೆ ಅಲ್ಲಿ ವೆಕ್ಟರ್ ಅದಿದು ಇರ್ತಿತ್ತು, ವೆಕ್ಟರ್ ಇರ್ತಿತ್ತು ಅಂದ್ರೆ ದಿಕ್ ಅದಿದು ಇರ್ತಿತ್ತು, ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಪೀರಿಯಡ್ ಆಫ್ ಟೈಮ್ ಇರ್ತಿತ್ತು, ಇಲ್ಲಾಂದ್ರೆ ಒಂದು ಇದಿದು ಇರ್ತಿತ್ತು, ಗ್ಲೋಬಲ್ ಟೈಮಿಂಗ್ ಇರ್ತಿತ್ತು. ಇಲ್ಲಿ ಮಲ್ಟಿಪಲ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ಸ್ ಕಳಿಸ್ತಾ ಇದೀವಿ. ದೀಸ್ ಮಲ್ಟಿಪಲ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ಸ್ ಕ್ಯಾನ್ ಆಪರೇಟ್ ಆನ್ ವಿತ್ ದ ಡಿಫ್ರೆಂಟ್ ಟೈಮ್ಸ್, ಓಕೆ, ಆನ್ ದ ಡಿಫ್ರೆಂಟ್ ಸಿಸ್ಟಮ್ಸ್. ಓಕೆ, these are the here the we are doing what? Here the collection of cores I am using, collection of processor I am using with the multiple instructions. Okay, multiple instructions. There are two types of MIMD are there. One is what? Here the shared and the distributed. Shared memory systems and distributed memory systems. Okay, I have the two types of MIMD. One is what? Shared memory system, another one is the distributed memory system. Okay, as you already studied this one in the third semester, you had studied, no, this one, shared memory system and the distributed memory system in the third semester DDCO subject. Okay, digital design and computer organization, third module. In the third module you have seen, you have studied this one as the shared memory system and also distributed memory system. There we have taken only separate, there we have not seen the processor, but we are considering here the with the help of processor and also memory system also. Okay, first you consider the shared memory system. For the shared memory system, you have, I'm using the collection of cores here. Collection of cores are nothing but the number of systems. Okay, number of systems. Okay, this one is what? Here the CPU 1, this one is the CPU 2, this one is the CPU 3. Okay, number of systems. Okay, yes, number of CPUs. Okay, these can be used. Okay, and also we will be having the, these are interconnected to each other. They are interconnected to each other with the to the memory system. Okay, to the memory system. What you are performing here, the memory management. Okay, shared memory system and the distributed memory system. We are the what we are doing, shared memory system. We are consider shared memory system. In the shared memory system, you have the collection of cores here. So collection of cores are nothing but the collection of CPUs. Okay, these can be connected. Okay, these can be connected, interconnected to the memory system, to the memory system, to the memory system with the help of the interconnection. With the help of the interconnections. Okay, this can be done with the separate buses, separate buses. Okay, okay, separate buses. This one we call the shared memory. Shared memory system. Okay, shared memory system, shared memory system. Just copy that figure. Okay, now onwards. Okay, now the MIMD onwards, we have the so many figures. Okay, explanation will be less. You have to write the some figures are there. This first model is one of the easiest model. Okay, okay, now onwards we have the different, so many figures are there. Explanation you can write of your own, but you need to practice this. Okay, okay, you have the CPUs. Okay, collection of CPUs I am using here. These can be CPUs are interconnected to the memory with the help of the interconnections. Okay, in the shared memory system, okay, I'm using the collection of the autonomous, okay, autonomous independent CPUs, okay, these CPUs, okay, so many collection of CPUs I'm interconnecting to the memory system with the help of interconnections, and also we have the some communicating, okay, these processors can communicate to the memory system independently with through the what here the interconnection, through what interconnect we are independently communicating to the memory system with the help of the interconnections independently. Okay, this one we call the shared memory system. Okay, shared memory system. Okay, next one you consider the distributed memory system. Next one I'll be okay. I hope you copied this figure, huh? Shall I erase? Okay, next you consider the second one is the distributed memory system. Okay, here we are doing the same. Okay, the same CPUs I am using here, and also separate memory. Okay, separate memory. Okay, these can be communicating with each other with the help of what here the interconnection through the separate buses. ಇವು ಲೈನ್ಸ್ ಏನಿದಾವ ಟೂ ಆರೋ ಮಾರ್ಕ್ಸ್ ಇದಾವ ಅಂದ್ರೆ ಇದು ಯಾವುದು ಡೇಟಾ ಲೈನಾ ಅಡ್ರೆಸ್ ಲೈನಾ ಹ್ಞೂ ಎರಡು ಸೈಡ್ ಆರೋ ಮಾರ್ಕ್ ಇದ್ರೆ ಏನಾಗುತ್ತಾ ಅಡ್ರೆಸ್ ಲೈನಿಗೆ ಒಂದೇ ಇರುತ್ತಾ ಡೇಟಾ ಮತ್ತು ಕಂಟ್ರೋಲ್ ಲೈನಿಗೆ ಎರಡು ಕಡೆಯಿಂದ ಇರುತ್ತೆ ಹ್ಞೂ ಆರೋ ಮಾರ್ಕ್ ಸೊ ಇವಿ ಯಾವಿಂದ ಟೂ ಆರೋ ಮಾರ್ಕ್ಸ್ ಟೂ ಸೈಡ್ ಆರೋ ಮಾರ್ಕ್ಸ್ ಮೀನ್ಸ್ ವಿ ಆರ್ ಯೂಸಿಂಗ್ ದ separate CPU and also separate memory. This one is calls the figure as the distributed memory system. There we have shared only the single memory to the multiple cores, okay, multiple processors, okay, and the collection of cores usually you share the conductor, okay, they are communicating to the memory with the only single memory, okay, but here the separate memory in the distributed memory system we have the separate memory, okay, for the separate memory, okay, with the each and every CPU, okay, have its own separate memory, okay. If you want to communicate with the one core to another core with the help of only interconnection only we will be communicating, but here the distributed memory we have the separate single, okay, all the CPU all cores have its own memory, okay. In a distributed memory system each processor will be paired with always with the of its own private memory on its own private memory, okay. This processor always communicate over the communication network. If you want to communicate from the one CPU to next third CPU or next CPU, okay, then definitely it will be communicated with the help of through what here the interconnection only. This is always we are if you want to send the any data between the one system to another system, definitely I need to send some explicitly I need to send the some commands here, okay, if you want to communicate from one system to another system, okay. This is all about the, okay, this is all about the distributed memory and the shared memory system and the distributed memory system with the single core with the MIMD, okay. If I use the multiple processors, okay, we'll see the next class. Same concept here is the I'll be using the single processors. I am using the collection of 2 to 3 processor. I am using the same figure will be there. Explanation will be same, but the multiple cores I am using with the single chip. Okay, I use here the separate chip. In the single chip only I have the only single CPU. If I use the multiple cores in the single chip, means what, that will be becomes what, shared memory with the multi-core shared memory system with the multi-core processors, and also we have the one more processor is there, shared. Okay, next is what here, the distributed memory system with the multiple cores also. That is also same, but here the in the single chip I have the single CPU, but in the distributed means multi-core we have the multiple cores as CPU1, CPU2 I'll be there, I'll be having there. Okay, we will be discuss that one in the next class. And also we have the, this is very easy subject, you can just theoretical is there, program, no programs are here, we don't have any programs here. But if I have the some small piece of programs there, wherever I need to explain some concept, there I'll be using the some small piece of code. Okay, give the attendance. 1 2 3 4 5 6, 3 na, 3 6 8 29 12 10 11 24 26 20 23 25 31 45 33. Hey, 13 ಆಗಿದೆ, ಇನ್ನೊಬ್ರು ಯಾರಿಲ್ಲ? ಇನ್ನೊಬ್ರು ಯಾರು ಹೇಳಿಲ್ಲ? ಓಕೆ, 3 6 ಇದೆನಾ? ಓಕೆ.